Still in section 3.7, problem 30 and several problems like it are asking you to determine something called the slant asymptote of each function. Now, a slant asymptote occurs in the case where the degree of the numerator is exactly one more than the degree of the denominator. So in this case we see the degree of the numerator is 2 and the degree of the denominator is 1 because of the largest powers of x in both cases. So there will be a slant asymptote in this case, and the way to find that slant asymptote is actually to use division. Okay, you have to use polynomial division. So in this case we are dividing the numerator by the denominator. Now in this particular case, since the denominator is a degree 1 denominator, meaning x is to the first power, we could technically use synthetic division, but that's not always the case, so it's better to use long division in this example so that it carries to your other examples. Alright, so to refresh your memory on long division of polynomials, what you want to do is take the first term of what you're dividing into and divide it by the first term of the polynomial you are dividing by. So in other words, in this case, x squared divided by x. Well, x squared divided by x is equal to x. Then, just like with regular division, you multiply what you have on top to what you're dividing by. So x times x is x squared. X times 4x, or I'm sorry, x times 4 is 4x. And then this line gets subtracted off of the line above. And I strongly recommend that you distribute the subtraction to all of the terms involved. Okay, so x squared minus x squared, those cancel. 3x minus 4x is negative x. And then we bring down the next term. And then repeat that process. So remember the process was divide, then multiply, then subtract. Alright, so let's do that again. Divide negative x now by x. Well, negative x divided by x is negative 1. Then multiply. Negative 1 times x, negative 1 times 4. And now subtract, and again distribute the subtraction to both terms. So that'll make them both positive in this case. So then, negative x and x put together cancel out. Negative 3 and positive 4 give me 1. So we can think of this part up top as being the quotient, and this part here at the bottom as being the remainder. We did all of that work to get a slant asymptote for this rational function. And the slant asymptote is always y equals the quotient of what you get from this division problem. So in this particular case, our final answer is that the slant asymptote has the equation y equals x minus 1.